Hey guys, welcome back to Maths Recovery with Rebecca. So today we are going to be looking at grade 10 trigonometry. But this is the first video, which means we are only going to be looking at the ratios, and we're going to be looking at how I can work with my right-hand triangle and get the sides, get the angles, get the lengths, get everything that I need to do. A little bit of Pythagoras as well. Anywho, let's look at this ABC triangle. It's a right angle triangle, which is trigonometry. What I'm going to teach you now is how to reference the lengths of the sides of this triangle. So if we look at C over here, this one would be baby C, this would be baby B, and this would be baby A. So depending on what the angle's letter is, the side opposite that angle is the baby letter of that angle. Another thing that we need to look at is, what do we call these sides? So we know from Pythagoras that the side that is opposite the right angle is the hypotenuse. But now, what about these other two sides? So in trigonometry, what we say is the angle, see the side C, the side that is opposite the angle that is stated, that is called the opposite. I know, right? So creative. And then the third side is called the adjacent. Now the reason why it's called the adjacent, the word adjacent means next to. It is the side that is next to the angle. Also very creative, you know? Adjacent, opposite, hypotenuse. That's the only one that's actually quite a big word. But it's okay, because we know it from Pythagoras. Let's look at the ratios now. Okay, so we've got the three ratios, sine, cos, and tan. And it's important for us to know this because this is trig, sine, cos, and tan. Now there is a way that we can remember it. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So here is something, sine, opposite hypotenuse, cos, adjacent hypotenuse, tan, opposite adjacent. So if you remember that, SOHCAHTOA. So you can say it to yourself in your head. SOHCAHTOA. Do we hear it? Sine is opposite over hypotenuse. So. Cos is adjacent over hypotenuse. Ka. Tan is opposite over adjacent. Toa. Okay. I've heard other ones. Silly old hens cackle and hackle till old ages. If that works for you, you can also use that. But I use SOHCAHTOA because it works perfectly for me. Great. So now let's see how this works. So there, I've got it there at the bottom, SOHCAHTOA. We've got our right angle triangle there, GKM. That's what our triangle's called. We know this is the hypotenuse. According to our angle, this would be the opposite. And then this side over here would be our adjacent. So if we look here on the side, this is how they're going to ask you. They're going to ask you, what is sine of K? Angle K. So we are always going to look from the angle that they are asking me to look from. So we are going to look from this angle. That is my, I don't know, very creepy face that I've drawn there. Looking from this angle. Sine, I know, is opposite over hypotenuse. So the opposite is going to be GM. Or what is the letter here? Baby K. Hypotenuse is going to be baby M. Adjacent is going to be baby G. And that's how we can see that. So K is going to be K over M, and cos G over M, adjacent hypotenuse, tan K over G. Now let's look from angle G. So now we're going to look from here. Let's draw our crazy odd man. We're going to look from here. So what does that make? That makes this now our opposite, this our adjacent. This is always going to be the hypotenuse because the angle is always opposite the 90. Sine G, so that's opposite, which is now our G over M. Cos, so that's going to be our K over M. And tan from G, that's going to be our G opposite over K. Great, hopefully you got those ones. So let's give this one a try. Now we've actually got physical numbers. Now let's look at sine. Sine of 30. So we are going to be looking from this side, making this our opposite, adjacent, and the hypotenuse. So I know that sine is opposite over hypotenuse. So that's going to be a 3 over, well, I don't have a length there, but I do know that I can find it out by using Pythagoras. We are solving for the hypotenuse, so let's take a look. The opposite is remember with Pythagoras, it's the hypotenuse squared is equal to the other two sides. It doesn't have to be opposite and then adjacent. It's just the other two sides squared and added together. And then to get rid of that square on the H, you've got to square root the whole thing. So I'm getting a 6 here. So that means this length is 6. So that's a 6, which is a half. Let's look at the next one. Tan of 30 over A. So that's going to be 3 over root 27. Let's look at sine 60. Well, where would 60 be? I know that the interior angles of a triangle need to add up to 180. I've already got 30 and I've already got 90, which makes this third angle 60 degrees. So now we're going to look from that angle. So looking from that angle, this is now my opposite and this is my adjacent. We're going to look at sine. So that's going to be square root 27 over 6, and then cos, which is 3 over 6, which is half. Great. I want you to pause it and give this one a try by yourself. Okay. Hopefully you pause it and try it by yourself. Anyway, let's go and work out this guy first. So I know that Pythagoras states that the hypotenuse squared is equal to the other two sides squared and added together. That's Pythag. Great. So let's go work that out. So I'm going to take this 13 squared. I'm going to take it, leave it that side, move the 12 squared over, it becomes minus 12 squared, and then square root that whole thing, and I'm getting a 5. So m is 5. So according to this angle, which is theta, this would be my opposite, adjacent, and always my hypotenuse. So looking from theta, because that's what this is saying, let's get sine. So this first one's going to be 5 over 13. Then cos is going to be 12 over 13. Now what is this? That doesn't make any sense. But let's go look. So the only thing that's unknown is this. How do I work that out? So I know that the whole triangle must add up to 180, the interior angles. So I've got angle L, I've got that theta that's there by angle M, and I've got 90. If I solve for angle L, I'm going to be left with 90 minus theta. So that is what angle L is. 90 minus theta. So now I'm looking from this side, this being my opposite, this being my adjacent, and this always being my hypotenuse. Sine is going to now be 12 over 13, the new opposite of our hypotenuse, and tan, remember tan is opposite over adjacent, which is now 12 over 5. So we want to leave it as improper, don't have to change it to mixed. Great. Hopefully you got them all right. Thank you for watching, guys. In the next video we are going to be looking at trig equations. Have a good one.